NASA is known for making incredible discoveries. They explore the vast universe, searching for answers to life's biggest questions. But even NASA was surprised by their latest find on Mars, a bizarre rock formation nicknamed Skull Hill. This strange rock has sparked a wave of curiosity and excitement among scientists back on Earth. Its unique appearance has left them puzzled, prompting a flurry of theories about its origins. Could this be evidence of something truly extraordinary on our red neighbor? The discovery was made by NASA's Perseverance rover, a robotic explorer tirelessly traversing the Martian surface. This sophisticated machine is our eyes and ears on Mars, equipped with cutting-edge technology to study the planet's geology and search for signs of ancient life. Join us as we delve into the mystery of Skull Hill, exploring the scientific endeavors underway to unravel its secrets. Prepare to be amazed by the wonders of our solar system and the relentless pursuit of knowledge that drives us to explore the cosmos. Perseverance landed on Mars in February 2021, touching down in a region called Jezero Crater. Scientists believe this crater was once a vast lake billions of years ago, making it a prime location to search for signs of past life. The rover is on a mission to collect rock and soil samples, meticulously searching for clues about Mars's history. It's equipped with a powerful drill to extract core samples, which will eventually be returned to Earth for in-depth analysis. As Perseverance explored the crater, it stumbled upon a peculiar sight, a small hill with an oddly shaped rock perched atop it. This rock, with its uncanny resemblance to a skull, quickly earned the nickname Skull Hill among the mission team. Its unusual appearance immediately caught the attention of scientists, prompting them to direct Perseverance to investigate this intriguing geological formation. Little did they know that this seemingly ordinary rock would soon become the center of a captivating Martian mystery. Imagine a landscape painted in shades of rusty red, the surface covered in fine dust and scattered rocks. This is the scene that greeted Perseverance as it approached Skull Hill. The hill itself isn't that tall, rising only a few feet above the surrounding terrain. But what makes it stand out is the rock perched precariously on its summit. This rock, about the size of a basketball, has a smooth, rounded shape, with two dark, hollow-looking eyes staring out from its surface. These eyes are likely just depressions or cavities in the rock, but their placement gives the unsettling impression that the rock is watching you. Adding to the eerie effect, the skull appears to be grinning mischievously, as if it knows a secret hidden from human understanding. This bizarre rock is a stark contrast to the surrounding landscape, which is dominated by jagged rocks and sharp-edged boulders. Its smooth surface and unusual shape make it a true anomaly in this alien environment. Scientists back on Earth were captivated by the latest images beamed back by Perseverance. Each new photo from the Martian surface brought with it a sense of wonder and anticipation as researchers pored over every detail, searching for clues about Mars's ancient past. Among the most puzzling discoveries was a strange, skull-like rock formation. Its eerie resemblance to a human skull immediately caught the attention of geologists and sparked a flurry of speculation. What could have created such a bizarre and distinctive shape? Why did this rock stand out so dramatically from the others scattered across the Martian landscape? The mystery only deepened when scientists realized that Skull Hill was located in a region believed to be made up almost entirely of sedimentary rocks, layers built up over eons by wind and water. Sedimentary rocks form over millions of years from the gradual accumulation of tiny particles, like sand, dust, and mud, often carried by ancient rivers or winds that once shaped the Martian surface. Yet, the skull rock's smooth, rounded surface seemed out of place among the jagged sedimentary layers. Its unique shape suggested it might be something else entirely, perhaps an igneous rock formed from volcanic activity. Igneous rocks are created when molten rock cools and solidifies, either deep underground or after erupting onto the surface as lava. Their textures and shapes can be very different from sedimentary rocks. The presence of a possible igneous rock in a field dominated by sedimentary formations raised even more questions for the team. Was this evidence of ancient volcanic eruptions in the area, or had the rock been transported here by some unknown force? How did this solitary rock come to rest in such an unlikely place? Was it shaped by natural Martian processes, or could it have been moved by a meteor impact or landslide long ago? Was the skull rock formed right here at Skull Hill, or did it travel across the Martian surface from a distant volcanic region, carried by ancient floods or powerful winds? The mystery of Skull Hill had officially captured the imagination of the scientific community. With every new image and data point, the excitement grew. The race was on to unravel the secrets hidden within this enigmatic Martian formation, and perhaps to learn more about the planet's dramatic history. When it comes to the mysterious rock perched atop Skull Hill, scientists have been captivated by its presence and appearance. Over time, two main theories have emerged to explain the origin of this enigmatic Martian feature, each offering a fascinating glimpse into the planet's dynamic history. The first theory suggests that the rock is what geologists call a float. In geological terms, a float is a rock that has been transported from its original location by natural forces, such as water, wind, or even glacial movement. This means the rock didn't form where it now sits, but was carried there from somewhere else. Millions of years ago, Jezero Crater was filled with water, forming a vast lake. During this time, powerful currents or even moving ice could have picked up rocks from distant locations and carried them across the landscape. As the water eventually receded, these rocks were left behind, sometimes in the most unexpected places, like the summit of Skull Hill. This process would explain why the rock atop Skull Hill looks so different from the surrounding terrain. Its unique appearance hints that it originated from a completely different part of Mars, making it a geological outsider in its current setting. The second theory, however, proposes a much more dramatic and violent origin story, a meteorite impact. Mars is constantly bombarded by meteorites, both large and small. According to this theory, the rock on Skull Hill could actually be a fragment of a meteorite that exploded upon impact with the Martian surface, scattering debris far and wide across the landscape. Such impacts have shaped the Martian surface for billions of years. Supporters of this idea point to the rock's unusual shape and smooth, almost polished surface. These features could have been sculpted by the intense heat and pressure generated as the meteorite blazed through the thin Martian atmosphere and slammed into the ground, breaking apart and leaving behind fragments like the one we see today. Of course, to truly determine the rock's origin, scientists need to conduct further analysis. By closely examining its composition and comparing it to known meteorites, researchers hope to finally solve the mystery of Skull Hill's remarkable rock. To truly appreciate the significance of Skull Hill's rock, we first need to explore the fundamental differences between sedimentary and igneous rocks. These two types of rocks not only look different, but they also tell very different stories about a planet's history and the forces that have shaped its surface over billions of years. Sedimentary rocks, which are found throughout much of Jezero Crater on Mars, are created from the gradual accumulation of tiny particles, sediments, that settle out of water or air over vast stretches of time. Picture countless layers of sand, mud, and mineral fragments slowly piling up on the bottom of an ancient Martian lake, each layer recording a moment in the planet's distant past. Over millions of years, the weight of the layers above presses down, squeezing the sediments tightly together. Eventually, this immense pressure cements the particles into solid rock, locking in a record of the environment at the time of their formation. This process can preserve remarkable clues about ancient environments, like fossilized ripple marks left by waves, or even the chemical fingerprints of water, and potentially the remains of long-extinct organisms. Each sedimentary layer is like a page in Mars' geological diary. Igneous rocks, by contrast, are born from intense heat and dramatic change. They originate from fire, not water. Deep beneath the surface of Mars or Earth, temperatures and pressures soar so high that solid rock melts, forming a seething pool of magma. This molten material is the raw ingredient for igneous rocks. When this magma eventually erupts onto the surface as lava, or cools slowly underground, it solidifies into igneous rock. The textures and minerals within these rocks reveal secrets about the conditions under which they formed. So, when scientists discover an igneous rock in a landscape dominated by sedimentary rocks like Jezero Crater, it's a clue that something extraordinary happened in the planet's past, something that disrupted the usual quiet accumulation of sediments. The presence of this igneous rock could point to ancient volcanic eruptions, a powerful meteorite impact, or other dramatic geological events that brought molten rock to the surface, forever altering the Martian landscape and leaving behind a fascinating mystery for us to unravel. Perseverance is equipped with a suite of sophisticated instruments to study Martian rocks and unravel their secrets. One of its most important tools is its SuperCam, a laser instrument that can vaporize tiny bits of rock from a distance. By analyzing the light emitted from the vaporized rock, scientists can determine its chemical composition and search for signs of organic molecules, the building blocks of life. The rover also has a drill that can extract core samples from rocks, which will eventually be returned to Earth for more detailed analysis. These samples will allow scientists to study the rock's mineralogy, age, and other characteristics in unprecedented detail. By combining data from Perseverance's instruments with observations from orbiting spacecraft, scientists hope to piece together the history of Skull Hill and its mysterious rock. Mars has captivated humanity's imagination for centuries. It's a planet of stark beauty, with towering volcanoes, vast canyons, and polar ice caps. But Mars is also a harsh and unforgiving world, with a thin atmosphere, frigid temperatures, and dust storms that can engulf the entire planet. Despite its challenges, Mars is the most Earth-like planet in our solar system. It has seasons, polar ice caps that expand and contract with the seasons, and evidence of past liquid water on its surface. These similarities make Mars a prime target in the search for extraterrestrial life. While no conclusive evidence of life has been found yet, the possibility remains that microbial life may have existed on Mars billions of years ago when the planet was warmer and wetter. The discovery of Skull Hill is a reminder that Mars still holds many secrets waiting to be uncovered. As Perseverance continues its exploration of Jezero Crater, it will undoubtedly encounter more intriguing geological formations and tantalizing clues about the planet's past. The quest to understand the origin of Skull Hill's mysterious rock is just one piece of a much larger puzzle, the search for life beyond Earth and the unraveling of the solar system's history. Each new discovery brings us one step closer to answering these fundamental questions. And as we continue to explore the cosmos,